All right, folks, I think we'll get started here. And this is really going to be an open discussion at all times. So I'm going to present some of the assessment tools that we use on the Multibeam Advisory Committee to assess the hardware health and performance of Multibeam systems. But at any time, this is an open discussion. So ask questions, tell me what your concerns are, or if something's not clear, just, speak up. And before we get started, I actually wanted to show a little video that Anand put together of a laser scan of the RCRVB Tani to highlight some of the work that he's doing, and hopefully he'll be doing more of with the Mac as well as more ships come online. We've had a couple of really good experiences where Anand saved the surveys of vessels that were in dire situations. And this is a neat little video. So I don't know, Anand, do you want to just play it and we can see what happens here?
Yeah, so what we are looking at just the dense point cloud. This is not just image, it's millions of point clouds, and we are doing this so that we have a greatly accurate positional awareness of what's underneath. If you need to plan something in the future, we have measurements that are accurate to 3 or 4 millimeters. We have a real-time picture of what was underneath. So I think
it should. Oh, it was.
That was Zoom, the demon for a while.
That's funny. It says it's playing. It's not actually playing. Let's try again.
We're doing this right now for some critical components like the iron room and the underneath of the board, so that we have the records. Long-term plan is to see if we can use this data to do some of the vessel offset measurements. Right now they are done with the row station, but this gives you like a realistic perception of where is what. So the video basically goes underneath the ship and shows you all your sensors in the installed position.
Okay.
It was playing until you expanded it.
Okay. Start over because we're only 4 seconds in. Yeah, not doing anything. Still going? All right, it's still going. I think maybe it's slow because it's trying to present it over Zoom. Not sure.
Okay, yeah. So these are our different point clouds. The idea got it to have some free software with this point cloud to do the measurements for planning and understanding purposes, like what are our sensors, how they are located. You can obviously take pictures when we are in dry dock, but this gives you access to measure 3D distances and 3D locations to 3 or 4 or 5 millimeters. So this is Tani looking from underneath. That's where the major sensors are. And yeah. So you can just click and do the measurement span in different orientations to really check few things. So that's the, and we have done this for a few ships, especially for the line units and the sensor. Sharing. That's, I think, the center board that comes out. So we had a lot of scans done on it to figure out how it's oriented, and the idea is to in the near future use this data to come up with some angles as well, not just the position. Yeah, so if you need something like this and you don't want to do it for the whole ship, you can obviously hire contract survey companies to get you this in using different equipments. But our idea is to help with critical components to have a record at different stages of verification. That's it. If you have anything specific regarding that, you can talk later.
Thank you. And I like that because it really sets the foundation for everything else that we do with testing. Getting those offsets is absolutely paramount to everything else.
So after that, at one stage, I think you were testing, so that is adequate now, but you think for the offsets and the angle, all this extra.
If we use a different high precision equipment, then it is adequate for position.
Right.
But we still are looking on and coming up with the software to pick few points out of those millions and fit planes and come up with the angles. And then we're going to do field testing comparison, confirm those angles are okay, and then we can start measuring the angles with this scanning as well. So this will reduce the time
Right.
and also give you all this 3D perspective data along with your total station surveys. Because right now the total station surveys are basically a report. You're just using final numbers. That's it, goes into your data. But along with that, if you get this ability to measure any point on the ship in a 3D space for planning purposes, that would be a very good thing. So in future, that's where we are going. But doing this right now slowly will give us the data, the background to do our stuff to figure out whether this is possible. And meanwhile, you have 3-4 millimeter accuracy, 3.1. So that's why we are asking about this data. Like you will come, we'll get that data, and background, we'll use it for studying this, but you will have this in a week's time with the free software that you can pan and consume to measure things for your ship. So that's the idea.
Yeah, so you would, if you're gonna hire a survey company, they're gonna often do it, you would need, are you gonna recommend kind of a spec for the scan of it?
Yeah, we can, yeah, we have a range, but mostly the survey companies that do that job are relatively more accurate.
Right.
So they maybe cost you more. We are experimenting, so our scanner right now is not that accurate, it's 4 or 5 millimeters. If you need position measure, you go up 3 millimeters, but right now the option is to hire a survey company to get that full scan within accuracy. It's up to the ship's need where they are going to use this 3D point cloud for what purposes that they need to decide. But we can certainly review your client or survey company's proposal to do this to confirm they will meet those accuracies. And I think Mac can. This is before you do the survey, or contract the survey to the survey company. So we just make sure we are agreeing to or they are using the equipment that can produce that accuracy.
Charlie, you had a question back there?
Yeah, so I think the goal is to work through a professional survey company with your like wants and specs inserted into that.
Yeah.
The way, at least from the NOAA side, is those packages are usually like scoped out like almost a year in advance. And then it goes through a pretty long bidding process. For at least from the technician side, to try and get that information to the port engineer and the project manager is Herculean from the technician side.
Yeah.
So is there a way to provide the technician the tools to be able to like spec out and hand off to a port engineer all of the language and requirements that are necessary so that nothing gets lost in translation? That would be a great benefit to the technician and the communication pipeline to identify like why this needs to be done, why it needs to be done to these standards, and what the outcome will be if left to a suboptimal surveying company, which I think several of us have seen the results that can come with that.
Mhm.
So whatever the tools that you put in place to make that process as easy as possible would be a great guidance.
Yeah. And call.
Yeah, agreed. And I think on the same line, we kind of have started doing a second document. So the Mac has a document on reporting standards, but we are also in the background working on a document that will have the wordings that can be taken and put in, so that the survey companies are obligated to meet and show you that they make the accuracies that are up there.
Yeah, that's fantastic because you have to remember, at least the NOAA side, they're going to get out to a subcontractor So then, like,
Mhm.
it's gonna just get subbed out as much as possible to the lowest bidder. And so the more that those standards are put in there in black and white, and that way that like no fly-by-night operation can jump in and do a crappy job and then run away with the money.
Yeah.
Yep.
Yeah, that's great solution, and then I think Matt will work on it and come up with.
Yeah, I hate to like just like throw ideas out for things that I won't even be part of the execution of, like identifying that kind of stuff, but like wherever like we can help, because I personally have seen what happens when it's taken a lazy approach and you get a crap product at the end, and then you gotta go back and start all over again for now double the money, if not more.
Yep. No, we could, this is so near and dear to our hearts that we should have done a whole session on just surveys. Maybe we will next year. That would be a good topic. And that's the argument we have to keep making, is that you pay for a good survey so that you don't have to go back into dry dock to do it again. And you don't have to deal with transducer offset errors for 10 years before your next survey. I mean, the way these multibeams work depends fundamentally on knowing those angles, and you can't solve for that in a calibration. So we'll just jump back on these slides for a minute and then we'll get into the tools. We'll see what we get through, but I really like these side conversations because that's why we're here. Just to go in a little bit more detail about our performance testing outline, how the Mac typically works with the ships. Again, this is by request from the vessel. Everything that we're talking about today is on the wiki or the Mac website. So even if you're not part of the UNOLS fleet, it's all public. You can refer to it, you can ask us questions, and we'd love to feed your experiences back into the Mac process as well. But yeah, as early as possible, start talking about the plan, picking sites, reviewing offsets, making sure we have a clear paper trail there, and do all the firmware and software updates to keep Colleen happy. And then we have a day dockside to do sanity checks. That's, for instance, this past year, that's when we discovered the burnt up TX cards. And so it's good we found that before we went to sea for a week. That's the final kind of dockside calibrations for antennas and that kind of stuff. And then just communicating with the bridge so everybody's on the same page about the plan, the weather. And then we'll spend 1 to 10 days at sea doing whatever it is to match the scope of the sea acceptance or the quality assurance testing. With Sikuliak, I think we had 12 or almost 14 days on board. That was with a lot of weather buffer built in it, and we used it. For more routine checkouts, we could probably just do a patch test, do some noise testing in a day, and then work some coverage testing into opportunistic transits coming up and that kind of stuff. And then of course the follow-up, it takes a while to sometimes just get all the final screenshots and do the analysis, but it does go on the Mac website for reference, and we're always referring back to those reports. And we can talk about any opportunistic testing. I wanted to just go over some other resources that are available. Like I mentioned, the Mac website. If you are starting from scratch, you could just go look at one of these reports and see, how did that go? Get some ideas about what the timing is for these things and what the workflow is. Again, the wiki, all public. We welcome any feedback and any contributions you want to make. Same with the test site database. This picture shows just the US sites that we've added. There are several more that are pending. This is not just the US though. We have sites kind of all over the world, and hopefully we'll just keep adding them. When you click on one of these sites, you get a ton of information about the waypoints, the settings, kind of a qualitative happiness scale on how happy we were with this site for its purpose. And then the web interface itself has a lot of planning layers built in. So Paul's been working really hard on this with the smart map ocean complexity. So you can look at sound speed variability that might be impacting your test site, especially if you're working at the edge of the Gulf Stream or something like that, where you have eddies spinning off. You can look at the weather forecasts, you can look at bathymetry and slope, and then I like to plan lines in the middle of the shipping lanes, so you can also look at the ENCs and make sure you're not doing that. But this is nice just to reuse sites that are proven and get that information quickly. As I mentioned in the earlier talk, we have a way to submit any sites that you know about and want to share. And the benefit there is that if you have more ships going to the same sites, you can make more apples to apples comparisons. So it's good for everybody. The Ocean Mapping Community Wiki is still out there. It's growing slowly. We use it. A couple other dedicated users check in with it from time to time and post issues. It's not a replacement for any manufacturer guidance, but it's just another avenue for all of us to share experience or expertise. As it relates to the tools that we're talking about today, there's a whole section on how to get the tools, how to collect the data for them, and how to use the tools. So a little bit more detailed step-by-step button clicking. So yeah, I just want to point out here, there's a whole section on using the tools and just, you know, examples here of one of the ships having major biofouling issues that noticed the swath was coming down. We do some noise testing and yep, noise levels are off the charts. Pretty simple test to do when you're talking about a full 1 water depth reduction in swath coverage for a deep sea mapping system. And then you clean the hull and you get that coverage back. So look, there's a couple of examples there on the wiki of use cases. And there are links to previous presentations with some other details about how to use the tools. So we're not going to get into like real crazy nitty gritty stuff about that. But I will switch over to just running the tools a little bit here. I want to start with that went away. Do you see anything, Marie? What's on Zoom right now?
System display.
Okay.
And- But
It's not
Did you
showing
stop
up here
sharing?
though. Nope. I
Yeah,
will
you-
stop sharing and then try
yes,
again.
Desktop,
Let me try again.
so it's sharing your screen, but it was just showing your desktop.
Maybe the lost it.
There.
Okay, we're back. Okay, so if you use Kongsberg Multibeam systems, you know about the built-in self-tests, and this is really the first thing that we do when we're checking out a system, make sure all the lights come back green. So we have, we've written these little Python tools that do some things that are just not available in commercial software and help us visualize things. Okay, we got the screen resolution issue. All right, hang on. Paul, you know, I have the setting, the resolution is correct, but when we do the projector, it reverts to something else.
Oh, it shouldn't.
And I can't. Yeah, that's not gonna work.
That's for sure. Here, go to your desktop, so we can see your desktop.
So one of the issues with the tools that's documented, because I'm not a great Python programmer, is that they only work at 1 screen resolution. There's a PyQt package that does the layouts. Yep, that's a known bug. And it seems like the projector's not handling that great.
Is that what
Yeah,
the
right.
buttons are also? Rigidity and
Right here.
spotter and stuff?
Yeah,
What if you use a different computer to the projector?
Okay.
use a different computer.
Use a different computer to talk to the projector and you'll just share your screen using it.
Oh, I think this is good.
Yep, good idea.
Let's,
Paul can't figure it
oh, we're try opening it up again. This plotter.
Oh. I usually have to restart it after. Okay.
Yep.
I will share my screen again.
out.
There.
It's.
Where is it? Okay, can everybody see the app in the correct shape? This is great progress. Okay, so this is our BIST plotter, and the idea is you can just drop in some BIST that you've recently created. Maybe you just hit run all BIST, you save, and yeah, we'll just do, for instance, actually, I'm going to look at the whole history of BIST for the Sally ride. So we can add a directory. Just say grab every BIST in this folder. So every ship has some folder on the desktop, and they've just saved BIST there for 10 years. You can add that directory, pick out what test you want to run. We're going to run TX channel Z because that's most important to start with. You got to make sure you can transmit, and then basically select your BIST. It'll scan each BIST in that directory, look to see whether there's a TX channels test available. If there is, it'll flag it and say, okay, let's plot all those. It'll take a second here. But this has been handy to watch hardware health over the history of each system. And you can watch for spikes in certain impedance levels somewhere on certain channels, or if a whole module fails, you see that. And hopefully this will just pop up with our plots. There's also RX channels and RX noise. We might go through those and how we're doing on time. But these plots alone have actually helped us make the case for $1 million systems. So, I mean, there's some value there. Thank you. So it'll go through and produce a plot for each of those BISs. It'll also produce a history plot. So you can look at your impedance measurements over time. This is really a proxy for impedance as measured through the multibeam. It's not the same as if you go to each element and you plug in an analyzer, but it's a nice proxy for that. And again, this has helped build the case for replacements of some systems. Just to look at what an individual test looks like. I like this visualization because you can look at this colored plot on the bottom and just say, oh yeah, this element is out of spec. So this colored bar is scaled to what Kongsberg says are the limits for a healthy element. And as you go through time, you can see sometimes certain elements turning on and off as good or bad, depending, maybe there's a cable pin issue or something like that. But yeah, these plots are helpful. They're what we use in our reports, and it's something you can do on board if you want to. Let's see about same with RX channels. I'm not going to go through that because it's very similar, but let's say wall files. I'm going to add an RX noise test. Yeah. So here we have, again, you can just select, it'll scan through any files you've loaded, pick out the ones that are suitable for the kind of plot you want to make. And then if we've lived a good, clean life, it will show up with an RX noise speed test. And here's a very quiet system. We've had cases where, this is in calm water, no major bubble issues or swell impacts, but this is really reassuring so that if you are having multi-beam issues, you can do a noise test, see if there's an optimal speed to run your system at. For instance, on the Gulf Surveyor, we just did this on Monday as we were getting set up for Friday training. And I mean, I think that boat surveys at 8 knots all day, and we just realized 8 knots is a very loud speed for that boat. Even for a 200 to 400 kilohertz system, it was not happy. So we're going to probably bump that down to 4 or 6 knots.
You always think it was the data assessment, just the one snapshot, and that's what you use, or if you average, you take a 5 to 10 to 20 average.
This is plotting every RX noise test in a text file. So if in Sys5 you can run continuous logging, which is what basically we've started doing, just continuous logging of RX noise channel or RX noise level BIS as the ship goes from dead in the water up to max speed and then back down. If we see a big difference between those plots, like here's an accelerating plot, we went from 0 to 10 knots over the course of probably 10 minutes. And we have 250-ish tests built into that. So this plot shows every single one of those tests stacked up. There's no averaging built in. When you get a wave hitting the hull, you see that as a vertical strike across all the elements. But if we see a difference between accelerating and decelerating trends, some ships, even the slightest extra propulsion load will cause a huge spike in noise. So in that case, we'll do discrete speeds. We'll do 0, 1, 2, 3, steady state, and collect 20 bis at each speed.
So, like, we treat this like the sea life or things like that.
Yeah, that's all presented here. It's not averaged in or out. And you can even see some little vertical stripes here. Maybe that was, yeah. Yep.
Sort
Yep,
of similar,
Robbie?
when you run it in, people sometimes run it in water that's still too shallow,
Mhm.
and the BIS test fails, and you get phone calls. Do you have any comments on that?
Yes, go to the wiki, look at the directions on how to collect the RX noise testing versus speed or versus swell direction. We have a separate test for that. And those instructions ask you to do that in the deepest, calmest water that you can find. So to Robbie's point, if you do this test in shallow water, you're going to hear a lot of reverberation off the seafloor, and your overall levels will probably be much higher.
Yeah, I'm gonna say, so it'll fail a channel and you get an actual fail, which if you run it again, it'll be a different channel. I mean, I think it's still valid to do it in shallow water. If you're looking for something, you just have to know correctly that's needed, but you just have to know,
Mhm.
Typically, as I see from my acoustic, failure is like off the scale.
Mhm.
This is just, it's outside of the parameters.
Yeah. Or if you're in a shipyard and you're hearing every other vessel around you, so it's atrocious.
So
Yep.
that script, that 20 kind of ops or 10 or whatever, you don't have to do that with Sys5 anymore?
You don't have to do that. Yeah, for Sys4, any Sys4 users out there, we do have an auto BIST script that will, you click the button once and then don't touch anything because it's a Windows script file. And it'll log 20 BISTs for you, so you don't have to keep clicking the button. We have fewer and fewer users of that, which might be a good thing. And the continuous logging in Sys5 is fantastic.
Okay.
Yep. So again, we can also do that test versus swell direction, because depending on hull shape and a number of other factors, there are some hulls that are very, very loud with a following sea, but they're actually pretty quiet going into the swell. Other ships are really loud with the swell arriving on port or starboard. And we can do this. It's not really a heading test, it's more of an azimuth relative to this prevailing swell direction. And you can figure out if there is a heading or an azimuth that is best for mapping. Whether or not that's best for the quality of life on board, that's a whole separate question. But we've had, basically two ships of kind of the same size and class and have completely opposite noise patterns on swell direction. It's been really interesting. And part of that might be bubble generation as well. So I think if there are no more questions on the BIS, oh, hey. Yep.
I'm still, so how shallow is too shallow?
Depends on the system.
Take the 20.
If you're in tens of meters, hundreds of meters, you're good.
Less than stuff.
Less than hundreds, yeah. It'll depend on what's around you too. Yeah, if you have other ships around generating that noise, but yeah, ideally you want to be as far away from the seafloor as possible, so you're not getting any bounce back from the hull, from the propulsion systems.
Multibeam says that this plotter work with.
This works only with Kongsberg EM systems. But it should handle, as far as we know, all the BIST formats for. Yep. EM 122, yeah, 124. There are some very specific installations where the BIST format it was a custom job. If you break the plotters, send us feedback, send us the example files, and we'll try to make it work. Those are really, really helpful actually to get that feedback. Any other questions on BIST plotting before we go on? I just want to kind of go to some of the other tools as well. Okay. After you establish that your vessel's quiet, or if it wasn't quite, you fixed the noise issues or at least identified a survey speed that works well. You can start looking at other indicators of multi-beam happiness. And one of them is swath coverage. This is really important for planning your survey, line spacing, of course. And you want to see what your actual achieved coverage is for your specific installation on your vessel might differ from the theoretical coverage. But we have a swath coverage plotter that will let you dump in a bunch of transit data over a wide range of depths. And assuming those have been collected with certain parameters, namely not limiting the swath width too much, you can generate a curve here, and we'll just go ahead and do this. So for instance, here is some recent data from the Armstrong EM124 off Blake Plateau. We just they ran some lines up and down across a deep, shallow to deep slope there. It's a pretty gentle slope. They cross the contours at 90-degree angles so that you don't have the slope facing toward or away from your sonar that could bias these results. And we just dump it into the plotter. It goes through, picks out the outermost port and starboard soundings for each ping, at least the ones that are flagged valid by the sonar, and then plots them versus depth. And we'll get there in a second. But the other reason we do swath coverage testing as routinely as possible is it can be the first sign that a scientist or a technician might notice that something's not right. You're not achieving the coverage you used to achieve. We're talking about this with a non-unol ship right now that is seeing pretty serious reductions in coverage and then some weird outer swath issues, and we think it's noise related. And age of the arrays. So this is a proxy for degradation of the transmit array, the amount, the energy levels going into the water, and then also the sensitivity of the receive array, getting those signals back from the seafloor. So this is literally just port and starboard outermost swath limits versus depth from, 800 meters down to beyond 4,000 meters. So this covers the region where the 124 is limited by its own design, so out to say 70 degrees or so. And then you reach a point around coming up on 3,000 meters where you start to see acoustic attenuation issues. Your swath that's coming in from 70 degrees, you might still be getting more coverage in meters, but you're getting less coverage in degrees. And this has a number of plotting options. We'll just go through a couple of them. I like to show, for planning purposes, you can show the number of water depths. So down to 4,000 meters, you're collecting 4 times water depths. And that's just a nice thing to think about as you're planning survey lines. You can add specification curves. Let's see if we have one for that. So this is a fake spec curve. Don't quote this on anything, but if you ask Kongsberg nicely, they'll make a file for you that says your sonar should achieve this kind of coverage based on these noise levels and this bottom type. And you can plot that alongside the real data to see how you're doing. In this case, we're lining up exactly as Kongsberg predicted. It's wonderful news. There are a couple other ways to plot this. You can filter, you can color, not by depth, but by backscatter. In this case, if you are going down a slope and you come across a really rocky or coral area where you have very high backscatter strength, that could bias your swath coverage results and make it look like you're achieving more coverage than you otherwise might. So you could filter, you can actually filter by that. I can filter by angles, get rid of some outliers so that at the end of the day, you have, let's see, a plot showing your achieved coverage versus whatever parameter you want to visualize. Here we have the ping mode of the sonar. So, or I should say depth mode, medium, deep, and deeper. We didn't get beyond deeper mode because this thing was in auto select. So it was just choosing whatever it felt was appropriate. So this is a nice way to sanity check that the system is changing modes the way you expect. You can look at pulse forms. You can see it used a regular CW pulse form down to about 2,400 meters, and then it switched to CW pulse forms on the inner swath and FM on the outer swath. They call that a mixed swath pulse form. We'd never got to deep enough for the system to auto select FM pulse forms. That would have been very deep mode or deep or further. So yeah, we use this just to visualize how the system's doing. I will go ahead and add some other. You can archive this. You can say, okay, on this cruise, we achieved this coverage. We ran this nice dedicated line up and down the slope. I want to save that for a future comparison. And then in the future, you can load that. What I'm going to do here is load. Let's see here. Kind of hard to see, but yeah. So like this. It's gonna make it a little bit easier to see, hopefully. Yeah. Okay. So the black points are a coverage curve from the Atlantis crossing the Puerto Rico Trench a couple years ago. And that was a really neat opportunity to go down to 8,000 meters. And so we had an EM304 Mark II on Okeanos Explorer, the Atlantis with the EM124. They both crossed the Puerto Rico Trench in kind of the same areas. It makes a cool apples to apples comparison of coverage versus system in the same area. Granted, the trench has steep walls, so there's some complication there. But if you own a system over a decade, you can watch the swaths change over time and use that as a proxy for other issues, either vessel noise or hardware health, and start planning replacement or other services that you might need. So I won't get into all the other options here, but yeah, some filtering options. I do want to highlight too that as the plotter scans each file, it pulls out installation and runtime parameters as well. So we've made that kind of searchable here. For our purposes on the Mac, this was really important to see, okay, if we're getting a report that some system started to do poorly at a certain depth, we can look back through the runtime parameters and see, was it in auto mode? Did somebody accidentally hit go to shallow mode and a weaker pulse? I don't know. We can go back through. You can scan through all the acquisition and installation parameters. The installation parameters are all checked on by default because we want any changes to pop up. Charlie? It doesn't identify filters. No. There may be a Kongsberg tool that does that to look back through and see what filters were on or off. Record viewer. Yep. So if you want to get more detailed into those acquisition settings, use the Sonar record viewer from Kongsberg. There's a new version out that's really nice. But this is, for our purposes on the Mac, we can at least sanity check that, okay, this data set was collected with the parameters we wanted. Nobody had set limits on the swath width, and everything was in auto mode, or it was changing modes correctly. Yeah, there's a lot here. Also, on the installation parameter side, we have had cases, not necessarily in the UNOLS fleet, but elsewhere, where somebody doesn't understand the sign convention for, say, waterline, and that if you are off by a few meters in 5,000 meters of water, maybe that's not the end of the world. But if you have a sign convention error on the waterline in 100 meters, that's 5% of water depth. So that will be flagged here. If there's any change in any of these installation parameters, you can load directories from one year and another and just see what changed from year to year and make sure that you understand why. And then, you can export this to a text file to send to Kongsberg. We had talked in other sessions about some transit mapping topics, and we have touched on these issues in other sessions. I just want to say from this plotter, we can export a coverage curve based on your ship's data that you can bring into this tool called Gap Filler that will help you plan transit routes, that will help you map in areas that are not yet mapped to adequate standards. So if you have a transit from one A to B and you want to go there, And the gap filler tool says, hey, offset this little bit here and there, and it adds 38 minutes to your transit, but you're gonna literally add 1,000 square kilometers of new coverage to the global grid. You can use that tool with a coverage curve that's exported from this plotter, and it will give you a more realistic offset for your line. So we're not planning deep water lines with the wrong system, or if your ship has older, maybe older arrays and it's not getting the full expected coverage, that can be built into the gap filler estimate of what your transit line should be. And I think there's just going to be more discussion about transit mapping in general and opportunities for the UNOLS fleet to add significantly to the global grids without really adding too much time to anything, just running the systems. Some other little features here. There is a, let's see, there's a data rate estimate here, which is kind of handy. So you can see in this system, in shallow water, it's producing a couple hundred megabytes per hour. That's not including water column data. If the directory that you point to has water column data in it, it will scale this estimate up with using those files. And it will start to tell you what you can expect for data rates while you're underway. You can see ping intervals. You can see cases where it lost maybe bottom track and the ping interval doubled almost to 30 seconds here. And it's just a nice way to visualize some of the timing and the other factors that go on. Speaking of timing, this was a request from Jules, looking at CPath systems. There was some concern about latency between when the datagrams get generated from the MRU. It's really it's literally the MRU's like raw timestamp versus when it arrives at the multibeam and gets timestamped by the multibeam. So we added this plot that just shows you in milliseconds what that difference is. Here we're talking 10 milliseconds, not the end of the world. But I think for Jules' needs, there was some concern that there might be bigger offsets. And in some cases we have seen some, and I forget what the resolution was there. But it's a nice sanity check that there's no major latency issues. Are there any questions about coverage plotter before?
Well, the offset with it, so
Mhm.
but the timestamp should be correct, right? It's interesting that it's 10 milliseconds late, but we should be using a timestamp that that the MRU assigned to the data, right?
I think this is the timestamp applied by the MRU through processing in the CPath, through the network, to the multibeam, and then timestamped by the multibeam. It's even earlier than I think the timestamp from the CPath, if I'm understanding that datagram format. So it's raw MRU
Can't quite
time.
hear you, actually.
Oh, yeah, we could maybe talk
Yeah,
offline
but
about that.
I'm just saying the timestamp that the MRU puts in, it's the one we would use, right? That's the correct. And like, why do we, I'm wondering what this other times, it's interesting, I'm just not sure where it would come into play. Although, as you said, it's a Jules question, maybe.
Yeah, we were looking for times when it might bounce up and down by hundreds or thousands of milliseconds.
Okay.
I think generally in this case, the data looked really good, and a 10 millisecond difference between the MRU raw timestamp through the CPath to the multibeam and applied by the multibeam. We weren't too concerned about that. I don't know is there an option maybe for the multibeam to use this timestamp instead and backtrack 9 milliseconds or something. So I don't know. Yeah. But
It sounds like what Jules is worried about is that she's probably processing something before the thing she wants has even arrived.
I think so.
Yeah, okay.
Aaron?
So I love your tools. They're really good.
Thanks.
Making them available.
Thanks, NSF.
Thank you. NSF. I can't ever see the button. So what is the
Yep.
resolution that this app wants for me to see the button?
It's 19 something by 1200. 1980 by 10. It's on the wiki. I've added it as the first thing that comes up on the assessment tools section because it's a
Okay.
problem.
Yeah, that's.
Definitely a problem.
And I was just reminded,
Yeah.
during the multi course of January, because it came up that if people would just start compiling coverage plots somewhere for people who are, because I always end up on the Mac site digging through your reports to try and find for different systems to get a feel for it.
Mhm.
And if people are worried about exposing their system, and they can just start like generically dumping them off, that would be
Yeah.
helpful. For the folks who jump around different boats and needs to know kind of what's going on.
Yeah, we could even add an option to color by system here, so you could just dump the whole fleet in, and then just color by system and not name names and just see.
Yeah, if you wanna, yeah, you could run it on
It wouldn't crash, but-
It would not, it never crashes.
Oh, I was
It's so
actually-
fast too.
But internally, it's like, one of the things we used to do, Chip and I talk about, is, that was just one of the, there was an output from every survey.
Mm,
Like, it was just the standard product, and it meant that internally on the ship, you got a really good track of what was going on. It's just a simple tool into the job, right?
Vicky has a point on that.
Yeah, so as part of MRT processing, we run this both at the beginning on the raw data and at the end on the process data. I have a broken link on my website right now, but I'm gonna fix that, so don't go looking right now. It's there for some of the older cruises. But we are generating these for every cruise that we review, and so part of what I try to do is let scientists know if they're gonna go on a particular ship, they can go to the GMRT website and look at recent cruises and see what the performance of the swap has been in terms of general data.
And just to go back to kind of the general idea that I'm not trying to show off button clicking here, but I'm trying to show why the features exist in the plotters and what it means for the vehicles or the vessels that you're using. There are some other options here to reference your depth to other things. So if you're not dealing with a surface vessel, you can do it to some other reference point, and it will hopefully make the right translations there, so that if you are collecting camels, but with a pressure sensor built into that, and it's making the adjustment for depth of your vehicle, you're not plotting your swath width of 10 meters versus a depth of 4,000 meters. It'll make those adjustments, hopefully. And if you break it, please let me know and we can try to fix it.
Think you were gonna break it?
Yeah, it's gonna break.
Okay.
It's gonna break. If there are no other questions on that, I'll just move on. Well,
Nope.
no? Okay. We'll go to swath accuracy. This is not something you might do as part of your, pre-cruise checkouts, but we are trying to make it possible for ships to find reference surfaces that exist already, well, trusted bathymetric reference surfaces that you can just run over on your transit with certain ping modes and assess your swath accuracy versus unknown reference. So this tool, again, it's maybe more geared toward Mac purposes, but I'll just show it off because it's a nice little indicator. So here's a Armstrong again, 2024 SAT. We surveyed a 4,000 meter. It won't let me add another reference site. So once you pick your reference site, it'll bring in that grid. This is processed in, say, Chimera or Keras and then exported to XYZ in a certain UTM zone. There are instructions on the wiki. You can add a sounding density plot if you'd like to. Again, instructions on how to export that elsewhere. And then this gives you some options to filter the reference surface by whatever parameters you think would make it a good reference surface. So if you want a certain sounding density, you want to minimize slopes on it. Sometimes we go to areas that have nice flat reference areas, but you have fjord walls on the edge of it. So we filter out the fjord walls and only use the nice flat bottom for reference. And then it'll bring in your reference grid and your density. And then we can run some cross lines here. And once you add that, you can also add tide. I don't know if we did in this one because it was 4,000 meters deep. I don't think we cared about a 1 meter tide. But if you're in shallow water, you definitely want to care about that. And then with any luck, it'll go through and take every sounding from those cross lines and compare it to the reference grid, find the difference, and then bin all those differences in 1 degree bins across the swath, and then run sort of a mean and standard deviation on those and present that. This is a feature that has been available in some other commercial software. The reason we made our own tool is that we wanted some more controls over plotting. So there are options to filter, like I said, the reference surface, but also the cross lines. And it's not fair if you have outliers in a swath that would, we're looking for kind of the bulk of the systemic performance of the system. If we're dealing with some outliers, it's good to note those, especially if they persist for, you know, all survey activity. But if you just need to get rid of that and look at the bulk of the data, you can run some options to filter by depth difference from the plot, and it'll recalculate kind of everything. And this looks great because we filtered it down to 10 meters, but we run, say, that 100-meter difference. It'll take kind of the more aggressive of this percent of water depth or meters difference. And we get a reasonable looking plot for swath accuracy out to 65 degrees for both sides. You can see the standard deviation of these depth differences goes up on the edges pretty rapidly beyond 60 degrees. But by and large, it's less than 0.2% of water depth, with no tide correction and in pretty soft, goopy seafloor. So that's actually not bad. The mean of the swath in red here is around 0% water depth difference. So that's also encouraging. If you do have issues like major refraction problems, like we did in some Norwegian fjords, we just could not capture sound speed profiles frequently enough to get the freshwater input. So there are some options here if you're in a dire situation and you just want to see the distribution of soundings, not necessarily the curvature of it. You can flatten the swath and just say, take out the refraction and just basically plot things flat. Let's see if it'll go. Yep. So this sets the mean as, yeah, it flattens the mean, keeps the standard distribution or deviations, and just gives you a clearer picture of how the swath is doing without any refraction issues. And then there's some other more nuanced features there. Again, you can reference the data to waterline or other things. If you discover a waterline error, you can adjust that here. So these are all features that have been added because they were necessary at one point or another to fix test data for some ship. And then we're coming up on the end. Are there any questions about the accuracy plotter? Okay. Last little thing, this is a quick little demo of a waypoint converter that was made by request from a couple users, and it's, you know, still a work in progress, but we've found that often the biggest hiccup in running these tests is not the testing itself, but sometimes just communicating the waypoint to the bridge. And that's no shade on the bridge. It's just that every ship is different. Some ships literally want you to call and read off the waypoints, and they write them in and type them into their specific ECDIS system. That's always fun. And we wanted to simplify that process a little bit because we were wasting ship time at some point, where lines get run the wrong way, especially if we're doing remote support. We're not on board to catch that in real time. The ship sends us the files, and the accuracy cross line is here, and the reference surface that they were supposed to go over is, you know, 10 miles away. And so unfortunately that wasn't a great use of ship time. But here we have, for instance, if you just dump in some lat long points, it's just a text file with lat long. You can choose whatever delimiter you want. You can have labels if you want in there, and then just say, let's see, I'm going to select my output directory. Yeah, that's good. Convert these. Oh, I got to select it. Convert this. Did it go? Yeah, it made all these text files. And these are all just different formats that are available. So different ECDIS systems, different ships have given us examples of exactly what they use. If you have an example from your ship you want us to add, just send us an example of what your bridge prefers. This was a thing on Sikuliak. Every ship we go to, we try to add their preferred waypoint format. There's some basic stuff for Fledermaus in here and sys ASCII plans, so you can load this right into your Multibeam. You know, HiPAC, Kongsberg DP if you're doing if the ship wants to use DP.
Those are the output formats,
Yep, it's the same waypoints that I brought in.
input formats.
Anything like this would work. Lat long, any delimiter you
Right,
want.
You said lat long, but I'm like.
Mhm.
Straight degrees, minutes, seconds, minutes, decimal degree, because this is the other way we run into, like,
Yeah, it tries to
gotta be
figure it
both
out.
ends.
Yep, it tries to figure it out. And if you look here in the activity log, it'll tell you what your options are for input for best results.
Okay.
And then you can try to make it flexible. You can also bring in a high pack LNW file and it will read that and spit those out to the other. Yep.
How about DPX?
I don't think we have that yet. So if you can send an example.
Sure.
Yep, that'd be great.
I have a question for any European in the room, because I've never thought about this before, but in latitude and longitude, you switch to the comma instead of the decimal point, like they do in other things.
Yeah, disaster. So
Yeah,
it won't handle that. Yeah, that won't work yet. We can make a European version that does
Right,
that.
but people can come in, like, okay, it's another thing to watch out for.
Yep. But just to, show some examples here. These are all the same waypoints in the same order. And if you had labels in that input, it will try to carry those labels over to the outputs if the output format allows a label. So we do this for patch test processing and planning. And yeah, we have some automated routines that just spit out these things and say, here's your pitch line point, to start and end. But just to show, for instance, the ASCII plan file, this is something you can drop right into Multibeam. And we did this on Monday and it worked. And it's always really nice when that happens. There's also obviously line planning functions in the Multibeam, but I think we just kind of like to do this in this way and then share all the formats, and then whatever the ship has, they can just use that. So I don't know, we're kind of out of time. Are there any other questions?
One more on that.
Yep.
Do you have any, you obviously it looks pretty good, but if you have any comments on GPS Babel, which I know people also use?
I don't know.
You don't know what it is?
I don't really know what that is.
Oh, it's just format converter for GPS.
Okay.
Position. So, yeah, it works pretty well, but it's clearly a lot more complicated to use. It's classic Unix where you have to, have the right input to get the right output.
Yep. Okay. Yeah. Yep, Lindsay.
Yeah, I just like to thank you guys again. As a non-Unix user, I'm sure you guys realize how lucky you are to have this and for NSF for distributing it to the community. It's helped my mapping, certainly make it better and save my data a number of times with various tools. Really.
Cool.
And yeah, you helped me learn new tricks. So you can teach an old dog learn new tricks sometimes, and I bug the shit out of it. I really appreciate it. So as a community, I'm not sure people realize how much a contribution it is in the particularly deep water mapping.
I think again, thank you, Lindsay, for that. And the theme again is just reach out to us, machelp@unals.org, and tell us what issues you're having, or post it on the wiki, and we're happy to talk about it and try to solve that. Anyway, thanks for listening, and we're around.